We're going to solve some logarithmic equations today for the second half of 4.5. So a quick little reminder, when you're solving an exponential equation, you want to get the exponential part by itself first. So divide by 10 on this one. And then take the log of both sides that matches the log of the base of your exponential function. So this one's base e, so we're going to do natural log of both sides. If you do that, you just get 3x on the left equals natural log of 1/2, and then you'll have to divide both sides by 3. So when we're solving our logarithmic equations, we're going to use some of the properties of logarithms that you already know. And just like on our exponential, you want to get your logarithmic part by itself first. So on this one, go ahead and divide both sides by 2, which will just give you log base 4 of 2x equals 2. Now switch it back to exponential form. So you know from your properties of logarithms that this is the same thing as an exponential equation that says 4 raised to the second power equals the inside of your logarithm. So 4 squared is 16 equals 2x, then divide both sides by 2 and you get x equals 8. You need to check these. So when you check them, you can plug it back in and check it all the way through. Like if you plug 8 in here, you'll get 2 times 8 is log base 4 is 16, which is equal to 2, since 4 to the second is 16. And then 2 times 2 equals 4. If you're confident in your work, you don't absolutely have to check it all the way. But you need to make sure that when you plug your value back in, your inside of your logarithm, which is called the argument, must be greater than 0. Because if you remember our graphs, logarithms aren't defined for values that are less than 0. They have that vertical asymptote. If you get something less than 0 when you plug it back in, you have to throw that solution out. So you might get no solution. If you're looking at this one, combine those into a single logarithmic function first. So when you put that back together, you'd be multiplying an x and an x to the 4th, which would give you natural log of x to the 5th. Switch it to exponential form. Remember, natural log is log base e. So you know that e raised to the 10th power equals your inside of your logarithm, x to the 5th. To solve something that's to the 5th power, go ahead and take the 5th root, which you could make that a decimal if you wanted to. I'm just going to leave it exact. That would be e to the 2nd power equals x. Again, check it in that you at least plug it back in and think about if the inside of your logarithm would be greater than 0 or not. I'm just going to check this one all the way. So if you plug e squared back in to your original, natural log of e to the 2nd is 2. That's e to the 8th inside there, so that would be 8. Add them together, you end up with 10. Looks all good. At least, like I said, go as far so that you can tell it's greater than 0 inside. Okay, this one, same idea. Condense it back into a single logarithm. So log base 3 of those two values being multiplied together. I know this is kind of a long video, sorry. But if you do this one, you're going to end up using the quadratic formula. Your favorite, I'm sure. Multiply these back together on the inside, and then you could combine some terms and rewrite it in exponential form. So I'm going to combo that. 3 to the 4th would equal 6x squared plus 16x plus 8. 3 to the 4th is 81. Now you've got a quadratic function, so you could get 0 on one side and then factor or use the quadratic formula. Guess what? It doesn't factor. So you're going to need to use the quadratic formula. So if you plug your values in to the quadratic formula, it's going to look like negative 16 plus or minus the square root of 16 squared, which is 256, minus 4ac, all over 2 times a, which is 2 times 6. Doing a little bit of simplifying, you have negative 16 plus or minus the square root of, if you punch that into a calculator, 2008 all over 12. I'm not going to break that radical down. I'm just going to do this one as a decimal and round it to 4 decimal places. So do both the positive and the negative version. I'll do the plus square root 2008 first. If you use a calculator, make sure you put the top in parentheses if you're plugging it in all at once. You should get approximately 2.4009. And then I'm going to do a little copy and paste here for my negative version. So if you're subtracting, you're going to get negative 0.0676 approximately. And then again, you have to check those both. If you don't go all the way, make sure you at least go far enough so that if you try them in the original, you know if the inside of your logarithm is positive or not. So if I try the 2.4009 in there, it gives me a positive value inside my logarithm, both the first one and if I try it in the second logarithm, it's still going to be positive as well. If I can write things down correctly. And then try the negative one in there. If you go back to the original and plug in negative 5.076 though, if you take that times 3, that's like negative 15. If you add 2 to it, it's like negative 13. So that's going to, which means that it is not going to work in the original, and we just get one solution, x equals approximately 2.4009. Okay, think back for a second to your exponential equations where you had bases that were the same. Like this one, it was nice, it was easy, you just needed your exponents to match. This is that in logarithmic form. So the easier one's actually in the middle this time. So if the two logarithms have the same base, if you want both sides of that equation to be equal to 0, what needs to match is the values inside of your logarithm. So set them equal to each other. My parentheses are kind of unnecessary. But subtract 2x from both sides, add 12. You're going to end up with 4x equals 20, so x equals 5. Again, check to make sure that that gives you a value greater than 0 inside your logarithm. And it will. It'll give you 18, and it'll give you 18 on both sides if you check it all the way. So x equals 5 is your solution. So if the bases match single log, just make the insides equal. Couple just last messier looking ones today. So you could switch this to exponential form and have 8 to the 1/2 equals the 4th root of 2x. 8 to the 1/2 is just the square root of 8. So let's make that square root of 8. And then if you think about solving for x, you're going to need to take both sides to the 4th power. Square root of 8 to the 4th power is square root 8 times itself 4 times. So like square root 8 times square root of 8 would give you 8, and then 8 times 8 is going to give you 64 equals 2x. Divide by 2, and you get x equals 32. Just make sure that when you plug that back in, you get a value greater than 0, and you do. No big deal. Okay, last one's a little bit messy, weird looking. You have a square root of log of x, so I do need to square both sides to undo that, which gives me log of x squared equals log of x. This is kind of like a quadratic. I have something to the second power and the first power. Let's get them both on the same side and then do a little bit of factoring. So you have a factor of log of x that you could take out of both of those terms. So when I factor it out of log x squared, it leaves me log x. If I factor it out of negative log x, I just get negative 1. So set each factor equal to 0. So log of x equals 0, log of x minus 1 equals 0. Those are both base 10, so let's rewrite them in exponential form. First one, 10 to the 0 equals x, so x equals 1. Second one, 10 to the first equals x, so x equals 10. So two solutions, it looks like. If you check them in the original, they both should work. So two solutions on that one.